In this video, we're going to be talking about solving systems of linear equations in two variables by using elimination. First, we want to discuss what a solution looks like. If we have two linear equations, they could form two distinct lines that intersect. That point where they intersect, that is the solution to that system. It is the one point that they have in common. So when two linear equations intersect, there is one solution. The two lines could be parallel, in which case they will never intersect and there would be no solution. Or it could be that the lines are the same line with a different scalar, so they look like different lines, but they are actually the same line, in which case the entire line is the solution. If two lines lie on top of each other, there are infinitely many solutions. So the first method that we're going to learn about is the elimination method. The elimination method, we try to eliminate one of the variables to get the other variable alone. This method is also called the addition method in some texts, because you are adding the two equations together while eliminating one of the variables. In this example on the left, it's already set up very nicely. The goal is to get one of the variables to add up to 0. You can choose to eliminate x or y. It doesn't matter. However, sometimes it is easier to eliminate one variable versus another variable. If we look at this set of equations, we already have a minus x and a plus x. Well, 1x minus 1x would be 0. They are already set up to eliminate. I don't have to do any work. I can just add the two equations together to eliminate x. So negative x plus x is 0, and 1y plus 1y is 2y. The equal sign comes straight down, and 2 plus 4 is 6. Now I have a linear equation with just one variable, and I can solve for y. So the goal is to eliminate one of the variables to get the other variable by itself. So I'm going to divide both sides by 2, and y equals 3. Now that's only half of the solution. Remember, our solution is either going to be infinitely many points or a single point. So we have the y coordinate. We need the x coordinate. I can take this y coordinate and plug it into either one of these equations. So I'm going to choose the second one because it doesn't have any negatives. Again, you could choose to plug it into the first. I'm just choosing the second one because it seems to be easier. So in the second equation, I'm going to replace y with 3, since that's what we found. Now I want to get x alone, so I subtract 3 from both sides. So the final answer is the ordered pair 1, 3. Remember, our ordered pairs always go x, y. So this system had one point in common, one solution. If you're unsure about your solution, you're not sure if you did your math correct, we can check these, right? This one point needs to be a solution to both equations if it's really the solution to the system of equations. So if I plug it into the first, replacing x with 1, replacing y with 3, I need to end up with a true statement. Negative 1 plus 3 is in fact 2. That works. I'm going to plug it into the second equation, replacing x with 1, replacing y with 3. 1 plus 3 is 4. That also works. This is in fact the solution. So, particularly on tests and things, plug in your answer to double check your work. Let's look at the one below. This one is not set up as clearly as the one before. I can't just add these and get 0. 2x plus 3x would be 5x, not 0. I could choose to eliminate x or y. Again, you can choose whichever variable you would like to eliminate or whichever one looks the easiest. For example, this one on the right, I see a minus and a plus already, so I wouldn't have to add any negatives if I eliminated the y variable. Over here, there are no negatives with the variables, so one of them is going to have to get multiplied by a negative number of some sort. I'm going to go ahead and just stick with eliminating x. They're the smaller of the two numbers. It's not wrong if you chose y. So if I want to eliminate x, I need the least common multiple of these coefficients, so 2 and 3. The first common multiple that they have would be 6. This common multiple would be 6. So the goal is to get one of these to be 6x and the other one to be a negative 6x. So I'm going to take this first equation, and I have to multiply 2 by 3 to make it 6. So I have to multiply the left side of the equation and the right side of the equation by the same amount to keep it equal. Now, if this is a positive 6, that means I want this second equation to have a negative 6x. I'm going to multiply the bottom equation by negative 2, right? Negative 2 times 3 would give me negative 6. Whatever I do to one side of the equation, I have to do the same thing to the other side. Now let's look at the new equations. 3 times 2x would be 6x plus 3 times 3y would be 9y. Negative 6 times 3 would be negative 18. And in the second equation, negative 2 times 3x would be negative 6x. Negative 2 times 5y would be negative 10y. And negative 2 times negative 11 would be positive 22. So the x's add up to 0, and then I have a positive 9y plus a negative 10y, which would end at negative 1y, or just negative y. And a negative 18 plus 22 would be positive 4. I need to get y completely alone, so I divide both sides by a negative 1, and y equals negative 4. So there's half of my answer. I still need to find x. I'm going to go ahead and plug it into the first equation since it has smaller numbers. Again, you could choose the second. There is no wrong answer here. So in the first equation, I have 2x plus 3. I'm replacing y with the value I found for y. So negative 4 equals negative 6. I'm going to simplify. 3 times a negative 4 is negative 12. I want to get x alone, so I add 12 to both sides. Now I have 2x equals a positive 6. Divide by 2, and x equals 3. So my answer is 3, negative 4, always going xy. Again, I could plug those back in to both equations, and I should end up with true statements if it is, in fact, a solution to the system. Now let's look at the two on the right. The first one, I see I already have a minus y and a plus y. So this is already set up for elimination. I don't have to multiply by anything. I can just add these two equations. 5x plus 2x would be 7x. Negative y plus y is 0 equals 15 plus 13 is 28. I'm going to get x alone. I divide both sides by 7, so x equals 4. I need to find the other half of this coordinate. I'm going to use the second equation here. It's not wrong. You should end up with the same answer if you use the first. But I'm just choosing the second because it has smaller numbers. 2, I'm replacing x with 4, plus y equals 13. 8 is 2 times 4. I subtract 8 from both sides, and I end up with y equals a positive 5. So my solution would be 4, 5. I would plug this back into the original to check to make sure my math was accurate. Alright, let's look at the next one. This one does not have a plus and minus of the same variable set up for me. I have to multiply these equations by something to make one of the variables add up to 0. As I mentioned previously, this already has a minus y and a plus y here, so I'm going to choose to eliminate y. You can always choose to eliminate x. You should end up with the same answer. I just don't want to have to throw any more negatives around than I need to, because signs can easily get lost. So if I'm going to eliminate y, I need to find the least common multiple of the y coefficients here. So looking at 5 and 3, the least common multiple would be 15. So I need a plus 15 and a minus 15. I already have the signs, I just need the value now. So what do I have to multiply this by to make it 15? I have to multiply by 3. Whatever I do to one side of the equation, I have to do the same thing to the other side. Same thing down here. I want to make this a positive 15y, so I have to multiply by 5. Whatever I do to one side, same thing to the other side. Now, once I do that, what are my new equations? 3 times 4x is 12x. 3 times a negative 5y is negative 15y. Will equal 3 times a negative 23 will be negative 69. My second equation, 5 times 5 is 25x. 5 times 3y is 15y. And 5 times a negative 1 is negative 5. If I did it right, these should add up to 0. Negative 15y plus 15y is gone. 12x plus 25x would be 37x, equaling a negative 69 plus a negative 5 will end up negative 74. And then I need to divide both sides by 37 to get x alone. A negative divided by a positive will end up negative 2 here. So again, that's half of my solution. I need to find my y coordinate now. I could choose either one of these equations. I'm going to stick with the second one because the y value is positive, so I don't have to worry about dividing out by a negative. So 5, replacing x with negative 2, plus 3y equals negative 1. 5 times a negative 2 is negative 10. Everything else stays the same. I add 10 to both sides to get the y alone. And negative 1 plus 10 would be a positive 9. Divide both sides by 3, and I end up with 3. So the coordinate going xy is negative 2, 3. And there you have it. So the steps are, we want to eliminate one of the variables by getting a common multiple between the two. They need to add up to 0 to eliminate. We solve for the first variable, plug that into either one of the other two equations to find the other variable. The answer should be a single point. And as we'll see later in other videos, it could be no solution or infinitely many solutions as well.